myself Deepak Maurya. In this video, I am going to explain you the theory of single fiber tensile testing. First, what are the two types of the fibers. One is the synthetic fibers, that is the man-made. Another one is the natural fibers that we are getting directly from the nature. So, for example, coir, that is the coconut outer covering fiber, quinoa, jute, cane grass, all we will get the fibers from the nature. When the fibers made by the human beings or the synthetically it has produced, that is a glass fiber, Kevlar, carbon fiber, aramid fibers, that is the synthetic fibers. So when we go in the market, generally the producer asks us and of what modulus of fiber we require, what the strength, ultimate strength of fiber we require. For example, when we are talking about the carbon, especially for the T300, carbon T300, the modulus of the carbon T300 fiber is 230 gigapascal and the ultimate tensile strength is 3.5 gigapascal. Okay, very high value for a single fiber. Okay, similarly we have the E, F and sigma of the natural fiber also. So how we are calculating these values, that is the main thing. Okay, so I will tell you how to calculate these values. Okay, I will tell you for both the glass fiber and the jute or the cane grass of any one of them. This is the bundle of the carbon fiber and this is the quinoa fiber. From this bundle of carbon fiber, this is the top. From this top, we are going to extract the single fiber and we are going to do the tensile testing of that fiber. In the upcoming video, I am going to explain how to make the tensile testing sample for the single fiber and how we do the test, all the things I am going to explain. Okay. The tau are designated by their total tax. Okay, what is a tax actually? Tax is the mass. Tax is the mass in grams per 1000 meter length of fiber. If there is a 1000 meter length of fiber is there, what is the mass? Okay, that will tell us the tax. So in this format, we are generally defining the fiber. So which is having the higher mass. So like that we can differentiate it. For example, if we want to do the tensile testing, single fiber tensile testing, so we should know actually of which text we are going to do the tensile testing. Okay, so these are the things are there. So how we are going to make the samples? So that's a very important thing for the single fiber tensile testing. So how we are going to make the samples? So here you can see making the samples for tensile testings. First of all, which ASTM we are going to use. So here we are going to use the ASTMD30. Just I'm going to show you here. The ASTM is 3822. 3822. So you can also go in the same ASTM 3822 and you will get the dimensions, what speed we are going to test, all the things. So I will explain you that all things. So how we are going to make the single fiber tensile testing? Okay, for that first we have to go in this stores and we have to find out the single fiber from these stores. Either it is a synthetic fiber or the natural fiber. We have to extract these single fibers. Okay, of the different gauge length. Okay, this gauge length we will decide from the ASTM. Okay, so now what we are going to do, we need the paper support. This is the paper we have cut from the inside the paper in the diamond shape. Okay, we have cut the paper inside. We have cut the inside portion of the paper. These papers are generally the calendar, a little bit thick, not too thick, just only thick. So now what we are going to do, this is the fiber. This is the fiber. Now, first of all, this distance is actually the gauge length. This is the gauge length. What is the required gauge length is there. Okay. Now, the remaining portion, either above or below, we will put the we will put the glue, okay, and then we will put this fiber and we will put the another uh, tab of paper, another the same paper we have to put and just put the clips here. Okay, so when I'm talking about the glue, you should know which glue we are going to use. You have to use the semi-solid glue. Especially the Bondtite is the best because it does not spread. Okay, if we are going, I these days I'm noticing students are using the Fevikwik. Students are using the Fevikwik. So Fevikwik is not a good option. Fevikwik is not a good option. Why? Because if you will drop a Fevikwik here, it is a liquid form, so it moves in the gauge length. Okay, and wherever it moves, it makes the fiber, so it makes the fiber brittle there. So we will actually the gauge length is actually going to be changed in both the side. So that is not counted when we are using the Fevikwik. That is my idea. So I'm avoiding to use the Fevikwik, and I will suggest to everyone use the Bondtite. Are there any other semi-solid resin is available that you can use it? So like that we have made the samples. So in exactly I'm going to show you in the next. This is the real, this is the real sample. Okay, here you can see the real sample. You can see this is the grip holding this paper support. You can see the paper support, I cut it in the diamond shape. After loading in the grips, we have cut this paper support from the sides so that the load is beared by the fiber only. Okay, load must be bear by fibers only, by fibers only. Okay, so that's why we have cut it from here. We have cut it from here. And you can see after putting the fiber with the glue, we have put this the same paper tab here. So that is the best way. Okay. So like this, you can make the single fiber tensile testing samples. That is very clear. Okay. That is the one thing. Now the condition, what are the inputs and outputs of the machines? Let's see. That's a very interesting thing is here. So you know actually we have the load cell. Okay, when we have talked about the load cell, then we must know what type of load cell actually we have to use here. Load cell must be very sensitive. Okay, so this load cell we are generally using from the 2 Newton to the 2000, sorry, I'm using the wrong thing, 2 Newton to the 20 Newton. Okay, 20 Newton or 25 Newtons maximum I can go the up to the 50 Newton of load cell. Okay, so that the accuracy will be the good. So we will get the force in Newton directly from the load cell. We will get the displacement from the crosshead. Okay, from the crosshead, and we will got some curve. We have got some curve. Now, in the next step, what we have to do, we are not interested in the force and displacement. We are interested in the stress, that is the force by area, and the strain, that is displacement by the gauge length. Okay, and we will got some curve. Okay. Now, what we are interested? We are interested in the linear region. We are interested for the modulus. If you will go and see the modulus in the linear region, that is stress by strain. Now the question again arises whether this strain is correct or not, whether this displacement is correct or not. Okay. So I have asked the same question when we have done the tensile testing also. So this displacement is not correct because this is measured by the crosshead movement. Okay, so why? Because there the play between the crosshead and the screw and the between anything is completely ignored. So this displacement is not correct. This strain is then not correct. Then how to calculate this displacement? That's the biggest question that I will just tell you in the next part. Before going there, the another question is there. We have not talked about the area. How we have to go and find out this area. Okay, I have just told you we have to go and find out the stresses here. Okay, this is the stress that is forced by area. So, what is this area? This area is actually pi by 4 d square. But I didn't tell you how to find this d, this diameter. After making these types of samples with the paper support, you have to put with the paper support in with the paper support you have to keep the sample besides below the microscope and you have to find out the diameter. Okay, now the what is the important thing while calculating the diameter in the microscope? Because this diameter is not this fiber is not in plane. Okay, so this microscope generally see the dimension in the plane. So what is there? You will see the this plane, then you will going to see this plane, then you are going to this plane. When you are going to see this plane, you will able to see these outer layers easily, but at the same time your middle surface will be blurred. Okay, so you have to reach up to the middle and you have to capture this side lines very clearly so that you will get the diameter nicely. Okay, so if you will go there in the microscope you will understand these things yourself. So you will get the diameter from there. So the stress is equals to, okay, there I have written the wrong formula here. Okay, here it will be the sigma. Sigma is equals to force by area. My terminology must be correct. Okay.
1.8, 1.92.
That we have strict to the string, that is string is equals to del by of L. So we have to find out the del. In the last video we have seen for the tensile testing we have used the extensiometer. Okay, we use the extensiometer. There is another option of using the DIC, digital image correlation. But here in this case the fiber is a single fiber. We cannot insert the extensiometer, or we cannot do the painting or the spraying with the paint for the DIC. So all these things will not work. In this case we have to find the compliance of the machine. That is the necessary things. So how we are going to find out the compliance of the machine? So first, this is the UTM, Universal Testing Machine. So we know that this part and this part is having some stiffness. So we are mentioning that stiffness with K, stiffness of the machine. We also know we are keeping the samples between the two grips. So there is a stiffness of the specimen also, and we are going to load it. When we are going to load this with a force F, we know the force will be the same in both cases, but the total deflection, the total displacement will be the displacement of the machine plus of displacement of the specimen. We know the stiffness is equals to force by of displacement. Okay, so what we can write the kt, sorry, delta t, we can write the delta is equals to f by of k. So what we can write it, f total force divided by of kt, total stiffness, f of the machine divided by the stiffness of the machine plus f of the specimen divided by the stiffness of the specimen. We know all these forces are in series, so they are equal. Okay, they are equal. So what is going to be happen there? So 1 by of kt is equals to 1 by of km plus of 1 by of ks. So we know the compliance is equals to 1 by of k or delta by of f. So can we write this kt, compliance, total compliance is equals to the compliance of machine plus of compliance of specimen. 1 by of kt is equals to ct, 1 by of km is equals to cm, ks is equals to cs, that is the compliance of the specimen. And we have to find this compliance of the specimen. The compliance of the specimen is equals to ct minus of cm. Okay, ct minus of cm. So if we will know the cm compliance of the machine, then we can find the compliance of the specimen, because the ct is whatever we are getting the force versus displacement curve. Whatever the force versus, one second. So whatever we are getting from the force versus displacement graph, because that is having the machine as well, machine as well as the specimen. Okay, so whatever the slope is there, okay, that slope will give us the total stiffness, that is k, that is f by of delta, that we will get it directly from the results. So how we are going to get the compliance of the machine? So that is the important thing that I am going to tell you in the next part. Okay, how to calculate this delta, or the important thing is how to calculate the compliance of the machine. For finding the compliance of the machine, what we have to do, we have to make the samples of different gauge length. Okay, first we can make a gauge length of any, just I am taking the any rough values. Okay, you can increase or decrease this, and you have to minimum make of 5 different gauge length. So I am first making the gauge length of 50 mm. This I am making the gauge length of 100 mm. This I made the gauge length of 150 mm. Okay, when we have, I have made the 3 types of samples: 150 mm of gauge length, 100 mm of gauge length, and the 150 mm of gauge length. And I will go in the same machine and I will do the tensile testing. After doing the tensile testing, what is going to happen? I will get the force versus displacement curve. Okay, this displacement curve is for the 50 mm of gauge length. Okay, from here I will get the K50. Stiffness for the 50 mm of gauge length, that is F50 by of del 50. Similarly, I will go and do the tensile testing with the 100 mm of gauge length. Okay, I will go and do the 100 mm of gauge length and I will get the stiffness. This is the stiffness of K 100 mm of gauge length. K 100 mm of gauge length, I got the stiffness. Similarly, I will go and do the tensile test with the 150 mm of gauge length. Delta. So I got the K 150, that is the stiffness of the 150 mm of gauge length. From here, what I will got? I will got the compliance. I got the compliance of C50. I got the compliance of 100 mm of gauge length. I got the compliance of 150 mm. How? 1 divided by of stiffness 150 for 100 mm of gauge length, 1 divided by of stiffness of the 100 mm of gauge length. For the C50 compliance of 50 mm of gauge length is equals to 1 divided by stiffness of 50 mm of gauge length. Okay. So now what I have to go? I have to go and draw the compliance versus gauge length curve. Okay, we know we have done the test for 50 mm of gauge length, we have done for the 100 mm of gauge length, we have done for the 150 mm of gauge length, like that to for 200 mm of gauge length, and we will got this some values. Okay, we have got some values for the compliance here. We have got the some values of compliance for the 100 mm of gauge length. Okay, just I'm writing C50, C100. We have got the compliance of for the C150 mm of gauge length. We have got the compliance for the 200 mm of gauge length, and we will go and we will plot the values. Linear regressions we can use, or the we can fit this data point, and what will be happen? This line will pass on the some intercept on the y-axis. What is this y-axis actually? We have done the 50 mm of gauge length, we have done the 100 mm of gauge length. When the gauge length will be 0, when the gauge length will be 0, then what will left? When the gauge length will be the 0, when the gauge length will be the 0, then there is the compliance of the machine left only. This is the compliance of the machine. We will get the compliance of the machine from this curve. So like this, we have to calculate the compliance of the machine after doing the number of single fiber tests. When we will got the compliance of the machine, for example, we got the compliance of the machine 0.008, and what is the unit? Stiffness की unit होती है. Is the unit of stiffness is equals to force by delta, that is Newton per mm. So here the unit is mm per Newton. Okay, mm per Newton. If we will know the compliance of the machine, then we can find the total compliance. Compliance of the specimen is equals to total compliance minus the compliance of the machine. Total compliance we are getting directly from the force versus displacement curve, what we have done the testing of the specimen, and cm we have calculated from here. That's the compliance of the machine. Now we got the compliance of the specimen. When we got the compliance of the specimen, we can go and corrected our e values. How we are going to see? The compliance of the specimen is equals to 1 by the stiffness of the specimen, that is f by of delta. And what is the delta actually? Delta is equals to FL by of EA into of 1 by of F. Okay, that is gauge length divided by of the modulus calculated from the, or this modulus actually we are interested by of A. That is the cross-sectional area, that is pi by 4 d square. From here we can find the EE is equals to L by of CS A. Okay. So like that we can find out the modulus of the specimen. So that is you have to do the correction for the single fiber tensile testing for the compliance. Okay. When we will calculated the compliance we and we have found the modulus, because now just I am going to tell you the again the stress we have got it directly, that is force by area. In this case the area must be accurate 5 by 4 d square. On this d we have to calculate it with the help of the microscope, or we can, if we are using the synthetic fiber, to maximum time the diameter is constant for all the samples. So there we can go for the SEM also. When we are using the natural fiber, this diameter is generally not constant. Then in that case we have to go and see the diameter of each sample. We have to go and see for the each sample. So stress is cleared. Okay. For the E values, okay, we know that we cannot use this delta by of gauge length. For that, we have done the correction by using the compliance of the machine. When we know the compliance of the machine, we can go and use the formula of, just we have just calculated, that is L by of CSA. Okay, that is a gauge length divided by of CSA. Okay, from there we can, sorry, I have written the wrong, CMES specimen, that is a E, corrected. Okay, from there we can go and find out, we have find out the E. So there we will got the corrected E value also. Have to explain the at what speed actually we have to go and do the testing. Okay, that is the last part is there. So we are going in the ASTM. This is the ASTM, that is D3822. Okay, and where we have came here, that is the rate of extension. So you can see it here, estimated elongation at break of specimen percentage, rate of extension, percentage of initial specimen length per minute. Okay, so first, if you have to do one or three tests, rough tests, then you will come to know at what percentage of elongation it is actually breaking. If it is under the 8 percentage of the specimen, then you have to use the first case. If it is 8 to 100, then you have to use the second case, the rate of extension. Then you have to use, just like that you have to go and use it. But in this in this ASTM, you will get the many other things also, that you have to go and read it, tensile properties of single textile fibers. We are using it for the natural fibers also. Summary of test method. Okay. Sampling apparatus and reagents, sampling, number of samples we have to do the test, preparation of test apparatus, calibration, preparation of test specimens, procedure, calculations, everything you will come and you will understand it here. So please read this ASTM. So this is the thing that I am going to stop is